So in the previous class we have discussed about improper integrals, few definitions. Okay, so what are those? Finite and infinite integrals. What is that? Finite intervals, lower bound and upper bound limit values are finite, is said to be a finite intervals. If it is an infinity, lower bound and upper bound, so it is infinite intervals. Okay, next, bounded function. So when you say that a function is bounded, it should satisfy both the conditions, lower bound and upper bound, then only it is said to be a bounded function. That function should lies in between lower bound and upper bound. But in case of monotonic, either any one condition it should satisfy, either monotonically increasing or monotonically decreasing. Okay, but here is bounded function, it should satisfy both lower bound and upper bound. Okay, next, proper integrals. So what is that proper integral? In the definite integral a to b f of x with respect to x, here the intervals are also finite and the function itself is also a bounded function, then it is said to be a proper integrals. Next point, what is that improper integral? Consider this definite integral, in this intervals are also unbounded, that is any one point infinite discontinuity point and the function itself is also unbounded. So in this improper integrals, three different kinds are there. Let us see one by one. Okay, improper integrals of the first kind. Say improper integrals of the first kind, in that consider this definite integral a to b f of x with respect to x. In this, either a or b, either lower bound or upper bound, either a or b or both a and b are infinite. Intervals of the integration is unbounded. Here the intervals are unbounded, but the function is bounded. Function is bounded. Let us see what is that unbounded and bounded. Say by considering this example, intervals are unbounded means any one infinite discontinuity point, that is infinity is there. So that is unbounded. Then how you say that it is a bounded function? By substituting these intervals in that given function, it should be a bounded. Say one by one, so it is finite only. If you put in place of x as infinity, 1 by infinity it is 0. Here it is minus infinity, e raised to minus infinity. Here e raised to minus infinity, it becomes 1 by e raised to infinity, that is 1 by infinity, again it is 0 itself. And here infinity and minus infinity, 1 by infinity, again it is 0. If you put minus infinity, that is also 0. So like this we say that function is bounded and the intervals are unbounded. So this is related to the improper integrals of the first kind. Let us see that improper integrals of the second kind. In this second kind, intervals a to b f of x with respect to x, both a and b are finite. Intervals are finite. Intervals are finite, but the function is unbounded. Here function is unbounded. By considering examples here, 0 to 1, these two are infinite discontinuity points. If you put in place of x as 0, it becomes 1 by 0, infinity. So 0 is said to be infinite discontinuity point. Then 2, if you put in place of x as 2, 2 minus 2, again it is 0, 1 by 0 it is infinity. The 2 is referred as infinite discontinuity point. So here both a and b are finite, but those intervals, if you substitute in that function, it becomes function becomes unbounded. Okay, so this is improper integrals of the second kind. Consider the improper integrals of the third kind. In the given integration, so that is a to b f of x with respect to x, consider this definite integral, in that a or b or both a and b are infinite. The intervals are unbounded and also the function itself is also unbounded. Function is also unbounded and the intervals are also unbounded. Such examples are referred to be improper integrals of the third kind. What is that? First, see here example, 0 to infinity e raised to minus x divided by root x is there. If you put x equals to 0, so it becomes 1 by 0, so it is infinite. Any one point, one or more points of infinite discontinuity, that function itself is unbounded. So these are the three different kinds of improper integrals here. In the first improper integral of the first kind, intervals are infinite. Function is bounded. Here the intervals are finite, but the function is unbounded. In the third kind, both the intervals and function itself is unbounded. Limit of a proper integral. When you say that this limit point for the given function is said to be convergent if that limit exists finitely. Okay? By substituting that given point in the given function, if it exists finitely, it is said to be convergent. If it tends to plus infinity or minus infinity, it is said to be divergent. Okay?